We're going to have a panel discussion here about Rollups and beyond. Welcome, gentlemen. Innovations, opportunities, and challenges. We got a panel full of co-founders, actually. There's Harry Kalodner, Alex Gluchowski, Jordi Baylina, Matt Finestone, and Kevin Liu will be moderating the talk. There's still a few more people coming in. Anybody else? Yes. We got 2 more chairs at the front. If people are feeling tired already in the back. Oh. All right, then I'll give the microphone back to Matt. Have fun.
So I can start. Hello, everyone. Welcome to our panel. I was approached by many people yesterday because they saw this panel and they said this is the most expecting panel for all the events. We have all the big players here, so they request me to throw some hard questions at them. So I said I will try. And so I understand it's a long day. It's very hot outside, so we will try to make our panel, as fresh as possible and as informative as possible. So to start, my name is Kevin Liu, the co-founder of Metis. We're an Ethereum optimized rollup solution, and currently we're also incubating another initiative called zkM. It's a general purpose zero knowledge proof system based on MIPS infrastructure. So I'm glad we have all these big players here. So maybe we can start with a brief intro. Everyone have 1 minute. Maybe Alex, you can start.
Sure, it's an honor to be here. Thank you, guys. I'm Alex, co-founder of Polygon Labs, a company behind zkSync. zkSync is a EVM-compatible zk rollup with the focus on the mission of making Ethereum more resilient with regard to sovereignty, like promoting the idea of freedom and scaling Ethereum to the extent of the real world, while keeping the properties that make it decentralized and valuable intact. And yeah, we're very excited to be here with great panelists.
Hello, I'm Jordi Baylina. I'm the technical lead at Polygon zkVM. We launched the mainnet on March, and it's zkVM. zkVM means that you can just compile, do any smart contract, compile using the same tooling, the same thing. You just deploy it on the zkVM, and it works exactly the same. And this is for me the zkVM. We launched it on March. We are working hard on that. Still a lot of work to do, and very excited on the future.
Hey there, my name is Harry Kalodner. I'm one of the co-founders of Offchain Labs, the company which created Arbitrum. I think I've been working on Arbitrum now since about 2018, and we've been on mainnet for, I think it'll be 2 years as of August. If you see me sweating, you can kind of decide whether or not it's because I'm nervous or because it's really hot out and I walked here. So, could go either way. And yeah, really excited to be here, and hopefully plenty of you here today have used Arbitrum yourselves and seen how both easy to use and vibrant the ecosystem is, and everything we have going on.
Hello, everyone. I am Matthew Finestone, a co-founder of Taiko, a zk EVM project as well on Ethereum. Some of you might have seen the talk just before this. It's a type 1 zkVM, so we prioritize Ethereum equivalence over some zk proving efficiency. We also aim to be a decentralized zkVM, so from the get-go to have permissionless proposers or sequencers and provers. Also very happy to be here. If I'm sweating, it's certainly because I'm next to these guys. I'm not hot, but yeah, an honor.
Okay, great. Lovely to have everyone here. So today we're going to start, we're going to have 4 questions totally, and I hope to control within 35 minutes. So we have some more questions leave to the audience to ask. So we're going to start from first one. Maybe I will start from Matt. You know, like in the recent article published by Vitalik, it mentioned everyone moving to rollup. No, I think that's true. Every day we see different rollups coming up, Optimist rollup or zk. You know, so in this kind of highly competitive environment, how actually does everyone positioning your project, and how? Or let's put it another way: what kind of challenge or key challenge you hope to solve to solid your positioning in this space? So yeah, Matt, maybe you can start.
Thank you, Kevin. Yes, I like starting from Vitalik posts because those are always, you know, clear markers of like where we are in the space, right? The rollup-centric roadmap, the zkVM classification, and just like a general comment, we're saying, you know, the competitive space and where we're going. All these guys have been building for so long. Their networks are all on mainnet. They've come a long way. In some cases, I've known them since you know, before testnet even. So it's just obviously such a fascinating space. I think we could all agree. We're lucky to be working in it and contributing to it. Taiko, I find compelling, and I quite like working on our positioning of the whole market map. Again, that's really, so that type 1, using Vitalik's classification, the Ethereum equivalence, we really find it has some nice properties. You know, Jordi was mentioning just write your smart contracts and it'll compile down and it'll work. We of course have that. In like to the extreme degree, there's no kind of edge cases that could pop up. And besides on the roll-up front, something we were just discussing is it's quite meaningful for Taiko to actually try to aim for Ethereum equivalence. We prove Ethereum blocks as they are. It's like, you know, Ethereum L1 block. So it's quite, it's a stepping stone for things beyond rollups, but for, you know, a snarkified L1 and for light clients. So that's quite nice to be working on that, even outside of the properties it endows to Taiko. And again, the other positioning that I'm just quite fond of is our commitment, and in fact, like on testnet, our realization of decentralized or permissionless proposers and provers. So anybody could kind of throw blocks at Ethereum L1. You know, it's what Vitalik calls total anarchy. That's how our testnet is implemented right now. Anybody could propose blocks. Anybody could prove blocks in like a pure race condition, which might not be optimal. You know, we have other schemes like auctions or stake-based schemes that could have different outcomes. So yeah, that's where Taiko's positioning is, on that kind of pure equivalence and that decentralization. That's kind of what we're working on.
Okay, good point. Yeah, please, Harry.
Yeah, so I think there's a number of things. I mean, I think like from the beginning, certainly in the place we started as kind of all of us being security researchers, and I think that like our initial focus was all on kind of the protocol design and the security and kind of very heads down in that, and it took us a lot of time and iteration, I think, to get to today's design. We like released the chain in August 2021, and then a year later we like completely replaced a large percentage of it with an upgrade we called Nitro. So it's definitely been kind of constant study and iteration to try to find, and I think kind of we started with security, and then the other big pillar we added in was kind of UX and kind of equivalence and sort of just the trying to have the experience of using the chain be as smooth and seamless as possible. And I think that like we're pretty happy with where we are today in that regard. And then I think kind of looking towards the future, I think kind of the big thing we want to see is sort of going and sort of we're kind of at where Ethereum is now from that perspective, in some ways better, but we want to kind of start thinking about growing even more and seeing kind of what new stuff we can do in order to make the chain even more accessible and usable and efficient, and kind of keep pushing out what's possible.
So security, UM, equivalence, user experience, and innovation, I would say. Yeah, okay.
Yeah, very similar. But at the end, we start we start from the base that we want to scale Ethereum, and this is the goal of the Polygon zkVM. And when I'm saying Ethereum is Ethereum as is right now, so following all the values that are in Ethereum, from decentralization, usability, and we want to be part. I mean, we don't position as a different chain. I mean, we position more as an extension of Ethereum, as a part of Ethereum itself. So that's why we want to be as compatible and as equivalent as possible to Ethereum, and we want to remove, or at least reduce as much as we can, but remove the friction for the applications. So for the developers, the developer that's deploying in the zkVM should not notice any difference that deploying in Ethereum or another EVM network. That's the positioning that we have. Of course, we have zero knowledge, which is important. I think this is important, especially for composability between rollups and so on. We believe very much in the zero knowledge, which give you this finality, and you can compose between networks. And and scaling as much as we can, and bringing this technology to as many people as we can.
Thank you.
So for us, it's always been like we were starting with the values, which I mentioned before, and which I think everyone embraces here. And we tried to engineer our way back from a vision of an ideal future. If I had to use one keyword to explain what zkSync is about, it's been future-proof. Like, imagine the final state. Like, what do we want to achieve? We want that anyone in the world can have access to Ethereum, which is going to be very cheap, like super, like basically affordable, right? At arbitrary scale. You can process infinitely many, not infinitely, like arbitrarily many transactions. And it's very easy to use. You don't have complications. You don't have like heavy mental models that you have to carry around. You don't have to worry about your seed phrases. You don't have to worry about gas, paying it in some like tokens. All this complexity has to move away. Like if we are talking about bringing billions of people in the end, it might not happen tomorrow or like next year, but in a eventual state, you have to solve all of these issues. And so, like we're sitting down and thinking, okay, what do we need to do in the protocol to be able to sustain that? And it was very clear that we have to solve UX, cost, and throughput in this sequence, while keeping like security and reliability are non-negotiables. Mm-hmm. Like if your protocol is not secure, like it's a minefield. One mistake, it's all gone. Right? So like we invested over $3 million in security audits and building security in depth with different things beyond just zero knowledge proofs. And we invested heavily in the operational infrastructure. We're not reusing Geth because we know of the limitations of basically Ethereum that you have to carry together. So we built a node completely from scratch in Rust. It has high throughput. We can process over 100 transactions per second easily with a sequencer. But like security, reliability are non-negotiables. The rest is prioritizing. So the UX was the #1 priority. We are the only L2, to the best of my knowledge, that supports native account. No, not the sorry, Starknet as well. That supports native account abstraction, but we are the only EVM compatible L2 that supports native account abstraction, which means every single account in zkSync is essentially a smart contract, even if it's an AOA. So you can do gasless transactions. You can pay for your transactions in any token, not in ETH, not in any like zkSync token, which we don't have, but in whatever. You have USDC, you can pay USDC. You have DAI, you can pay in DAI, or the contract can pay for you, right? So like, and so this means that you can do things like Argent, for example, is only on zkSync and Starknet for this exact reason. Like the best smart contract wallets with account abstraction needed at the protocol level. It cannot be added like AP 4844, 4357 is a great step for Ethereum, but it's not quite there because they had to like maintain this legacy. And maintaining the legacy, keeping the legacy makes you not exactly future-proof. So account abstraction is one thing, and the next priorities are the costs. And for the costs, off-chain data availability is going to be a huge point. So we are working towards a evolution where you will be able to extend the rollup accounts with zk Porter accounts that have access to the same state and this instant synchronous access to all the protocols on the rollup, where LPs are providing value at high security from Ethereum, but retail users will be able to access it at like a sub 1 cent transaction, irrespective of the gas prices on Ether. So dunk sharding will give us some boost, but it's not going to be sufficient.
Great, great. So, for now, Optimist rollup occupies around 80% of the market share. As Harry mentioned, it's EVM equivalence, user-friendly, and a lot of users and builders are here. And for zk rollup, it can achieve instant finality and a lot of innovations going on. But I think you still have a very big challenge about EVM equivalence. So giving this kind of context here, also people still hold people hold this kind of view that zk rollup is the future. So how do everyone see this point? And if this is the future, how are you going to make this transition happening? So maybe
I would not say it's a future. I mean, I think it's a present, and here we have two examples. I mean, we are already there. The question is the degree of maturity. Of course, yep. Networks needs to mature, and it's a lot of improvements needs to happen. Even users and developers needs to understand even how to use these networks, and so it's a time. I mean, it requires evolution. But saying today that zk rollups' future is not realistic. I mean, zk rollups are present. They are usable. They are usable today. Of course, optimistic rollups has been running for a couple of years already there, so they have probably more experience in running rollups, so you have this advantage. But it's a present. I mean, it's a present. It's a matter of evolution, and we will see how fast we evolve this technology. My feeling is that at this point, it just starts exploring. I mean. Believe that very soon we'll see that everything's running in layer 2s, if it's not yet. I mean,
your point.
Yeah, I mean, I guess it's interesting, and I think being like not a zk rollup in a world where there's a lot of discussion about like, oh, zk is the future, and I think when they say zk is the future, I think it I take that more as like oh, everybody's going to be on zk rollups and not on optimistic rollups. Which is,
I would bet that Arbitrum is going to be a zk rollup very soon.
Well, that's a really interesting.
But to be honest, I hold a different opinion. But yeah.
Yeah, no, I mean it's an interesting and it's certainly an area we've explored and looked at. I mean, I think like so far, the view we've had has been that like it's a very promising type of technology, but that like there are kind of significant associated risks just purely from a complexity standpoint. Like the complexity of a zk rollup to me is like a couple orders of magnitude above an optimistic rollup, just because there's a lot of very complicated math.
I would say the opposite. I mean, the optimistic rollups. Just thinking on all the gaming theory that's behind optimistic rollup and all the challenges and what happens if something happens in the network and if the validators they just collide. I mean, if you think in all this and all the overhead that is generated. Of course, I mean you tend to appreciate maybe more what you don't know on that, but it's like I'm more scared on this than in the math, because
I think it's even Vitalik's point of view. He had a post about complexity where he dives specifically into this, and I think he supports Jordi's point.
Well, I'm just excited that we actually reached a point of disagreement, which is always, you know.
That's the point.
The number of people in the world who can actually like understand the details of how a ZK proof system works, I think is probably at least an order of magnitude lower than the number of people in the world who could understand, especially with machine-checked proofs that are feasible for optimistic rollups, how the protocols.
But at least we see ZK proofs in production. I've never seen a fraud proof actually being triggered, so we don't know if they exist.
Nice.
Look up our code base and you can see. And they actually have been run, interestingly. This is just like a random aside, but a little while ago there was the ETHPOW fork from Ethereum, and there was code set up that kind of made Arbitrum on ETHPOW completely permissionless. Essentially, if Ethereum forks and there's a version of Arbitrum that'll fork with it because L2's fork, if the L1 forks, that had permissionless validation on it. And actually, there were a number of fraud proofs because people were trying to steal funds out of Arbitrum, since for some reason there was still value in the system. And so a number of real fraud proofs occurred there.
And the cool thing also on the ZK is that anybody can monitor the network, and even if you don't care about the proof and all the math on the proof, but at the end you have the same that the Arbitrum has. That at the end you can check the network, you can monitor the network, you can check that it's evolving in the same way. So even if you don't trust the proof, and the ZK, it's. It's an optimistic rollup with a validity proof, but it's an optimistic rollup without the proof. It's an optimistic rollup. So even that, it makes no. So today, of course, the question here is what's the cost of generating this proof and how difficult it is to generate this proof. But at the moment that we know how to build and we know that these proofs are cheap, that they are not important. I think that making rollups that are not ZK, you can do it, but it's if you have it, why you would not have that if you already have it? That's the thing.
Right. Yeah. I didn't want to jump in with these guys, but I really like that question. I almost feel like it's one I could have planted. We're a bit departed from it, but I didn't plant it. I promise you. But we're saying optimistic rollups are so popular with their equivalents and their nice UX, and I like to think of Taiko as starting as an optimistic rollup and then adding that validity proof, not ripping out any of the Ethereum complexity that is difficult to prove, but kind of doing the difficult work up front on the circuits and eating some of those costs, but to keep that nice optimistic rollup experience plus the validity proof. So not to be overly diplomatic here, but maybe we're somewhere in between. We have the best of both worlds, and then even the best of both worlds taken to the extreme, even outside of Taiko's stance of full equivalence plus validity proof, might be, so we're betting that, Arbitrum could become a ZK rollup, maybe whatever, different opinions. But, Vitalik talks about multi-proof systems. If we find the math scary, then we could have, you need 2 of 3. You have a fraud proof, you have a validity proof, you have a governance system in check, you need 2 of 3. So maybe we do all converge. But again, that's why I really kind of like where we are, because the proof of Arbitrum and optimism, getting those developers and getting those nice UX benefits, that's really what we want to harness. I guess I'll say one further point, a bit of an extreme point, but back in the day, I used to work on Loopring, which was the first ZK rollup, okay? Not first ZK VM, but I think non-controversial to say first ZK rollup. And that was application specific, of course. Back then it was like a dream to be generalizable, and then it happened much quicker than we can expect. But we kind of saw firsthand, again, it's a bit of an extreme example because it's application specific, but the work you need to do to get users on there, to get infrastructure to support, it's just so difficult. It's so nice to just take, I don't want to call it the lazy path, but the easy path of just Ethereum, it's really nice. And look, Loopring has a viable path, and now app chains and app-specific rollups are all the rage as other L3s and stuff. But if you're trying to be a generalizable smart contract platform, it's just so nice to just, breathe in Ethereum.
So I also like to add a strong opinion to this question, and I will begin by again saying like the relative complexity of implementing both systems is comparable. It's not with zero knowledge proofs, the complexity is isolated in cryptography, and the reason it took us so long to arrive at compatible EVM equivalent solutions is like we just needed to break through on the cryptographic protocol level, and this took a couple of years. Now that we have the primitives, the rest of the work is pure engineering. It will arrive, and it's easy to verify. Like there are a lot of eyes on those protocols and on the cryptographic constructions. The real question is like, is there a fundamental difference between what the ZK proofs or validity proofs and fraud proofs can offer? Number one. And number two is what's the fundamental difference in the costs? And I would argue that ZK proofs can offer something like entirely like a 0 to 1 jump that optimistic rollups can't really like follow with, specifically with regard to objective testification of like proof of validity, like proof of integrity of computation that the machines can understand, that other systems can understand. Why this matters is because in the world where we're building something that scales indefinitely to millions of transactions per second, and I'm not exaggerating, like this is really what's, like if you take all the payment transactions and trading on all the world's exchanges and all the like bonus points, all the value flows in the world, we will end up at millions TPS that actually go on every day. So like if all of that has to go on chain, we need to come up with systems that can handle this load and can trustlessly talk to each other. And you will then end up with, like, if you think it logically to the extension, you will end up with designs like zkSync's hyperchains or Polygon's zk supernets. Like with the what we call hyperbridges, I don't know what you guys call them, but like it's a very similar design where you can trustlessly pass the message from any point on any chain to any other contract or like address to any other chain without trust assumptions, without basically with very, very low latency, depending on your willingness to take trust assumptions. Can be close to instant, can be like a slight delay, doesn't really matter, like not 7 days. And you can also pass value in the same way, like as a native bridge. Not the way the bridges work today. Today, bridges are completely broken. Like most bridges are basically custodial multi-sigs, yeah. In like down to the essence, it's multi-sigs, right? So you can't really, unfortunately, you can't do it with optimistic rollups in the same way. And this is why I believe you guys will have to face like a choice. Like, do you want to embrace it or you just can compete? And I think you will want to embrace it. And you are like all the teams present here are really like, I think the real divide is not between optimistic and zk, it's between the doers and talkers. You know, like so like here we have really like teams that have capacity to do things. Like I hope guys you will soon transition, But then, like the change makes only sense once the costs are actually affording this, right? For EVM compatible chains, EVM equivalent chains, we're already there. With like the proofs are negligible. We just, like, if you guys followed the news, we announced the switch to a new proof system this week. It's actually live on mainnet in shadow proving mode. So for blocks we produce with the old proof system, for exact same blocks, exact same state transition, exact same headers, we produce also proofs in the new proof system, which is Stark based, or like we call it Redshift. Came up with this name a couple of years ago. Yeah. It's really, really fast. But for some applications, like application-specific trading with hundreds of thousands TPS, it's probably not enough yet. So we'll still need to wait for more breakthroughs.
Great point. So,
yeah, I just want to. Man, I feel like kind of ganged up on. I'm just like surrounded right now.
But I'm with you.
Yeah, but you're the moderator, so you can't be too biased.
Okay, I will try.
No, I would just say like it's interesting. I mean, like we one of the few scaling teams that like didn't put optimistic or zk in the name of our company. It's definitely not an area where like we and like I said, a year after launch we like threw out most of our original tech and replaced it. Like it's not I'd say like there's the goal and then there's how you get there, and I think the important thing is the goal. And so like I think like our sort of general position is that like it's interesting and kind of we're definitely not sold yet, and I think there are a lot of real trade-offs, and I think that like as these other systems like spend more time in production and get more experience, I'll be really interested to see how things evolve. And I certainly would not say that I don't think it's going to be the end state. I would just say that I'd still hold out in that kind of and I would say kind of to one argument against the zk kind of future, I would say is to me would be flexibility, in that optimistic systems are kind of very flexible in that kind of you can do almost anything. You don't really have that many constraints brought on by the technology you're using. And so I think kind of whether or not those constraints matter or don't matter will be an interesting question. And I'm going to be disagreed with here, so I'll.
No, I think it's an historical. I think it's an historical concern, and it's right. Everything. I think that this concern. I mean, we can do everything today. We can do everything in zero knowledge.
Oh, so just like in one small example, later this year we'll be releasing. This is a project that we announced a while ago that's still under production, so not released yet, but we're working on, called Arbitrum Stylus, that's going to allow for WebAssembly smart contracts. So programming in Rust, for example. I mean, not that that's not something that you couldn't also do in a ZK world, but to me, the circuit design work takes a lot of time.
You don't need any circuit design. Like we have our compilers LLVM based. So like EVM source languages are just one input. Rust would be another input where you just compile. The circuits are, you know, like we run the virtual machine, which is optimized for snarks. So, but the virtual machine can execute an arbitrary trace written in any code. I think you're talking more like, I would agree with your point that like optimistic rollup give you more flexibility in purely computational terms today. So you have to see like what is the cost of computation. Like if like we do this transaction or this number of transactions per second, like what does it cost us? Today the costs are dominated by data availability, so it really doesn't matter. It really doesn't matter. Like it's tiny compared to data availability, and I think it's going to remain like this. And even for like ultra high throughput applications, in a year from now, it like just be completely irrelevant.
Yeah, but I see your point, and it's a good point, but it's not. I mean, at this point, it's not. I mean, there are projects, for example, like ReZero or projects that are emulating processors. I mean, that's if you can compile. I mean, we are getting there. So this argument, I understand for reasons. I mean, if we talk about that 2 years ago, it's definitely a valid argument. But it's an argument that with the current stage of the technology is not. We can do everything right now in ZK. The proof is, I mean, is Taiko. I mean, they're building the type.
Thank you, Jordi.
It's like, but it's hard. I mean, if you see the Ethereum and you see all the history in Ethereum and you want to encode that in a proof, it's really complex. I mean, it's Patricia trees and it's DAO hard forks and there is you all these things you can embed it in a proof. That means that you can
support
do
hard forks then.
Yeah, why not?
Historical hard.
So, yeah, I think I respect everyone's point. You know, this is from technical point of view. You know, it can happen, but from the user perspective, you know, we have so many TVL here, so large user community in the OP space. How this transition can happen, actually? You know, Metis started from layer 2, Optimist rollup, and we understand how hard it can attract TVL, attract users, attract activities. So actually, I'm thinking we might start another way. You know, we can combine, as Matt had mentioned, we can combine the best part from both worlds. Yeah, we use the flexibility of Optimist rollup, and then we can also utilize the fast finality from zk proof. Hybrid may be the way. You know? So maybe we can have this consensus.
No, I mean, we already talked a little bit before, but I think that the other rollups, they are converging very much. And we will see in the future, especially EVM, I mean, the EVM rollups, we are converging to a single kind of rollups. I would say that the rollups will be closer one each other, and the differentiation between them are not going to be as big as it may be right now, and we are already seeing. I mean, if I compare, for example, Polygon ZKVM with Arbitrum, of course there are some differences. But if you put ZK proof to Arbitrum and we improve a little bit the usability, we will not get very different things.
But you would be very different from zkSync and Starknet, for example.
It's because zkSync is not EVM. It's not EVM. It's another thing. It's another world. You build your own tooling. You need to have your own compile. You need to have your own compiling. You need to have your own tooling. I mean, it's like a Star Wars. I mean,
sure, but from the user perspective.
Okay.
The user perspective. I mean,
interesting.
I would not.
Do we have reporters here? I think I have a headline for you.
I want to try. I have another point. I have a point that I think we might all agree on. Maybe, we'll see. I generally think that in, like, let's just say 5 years' time, all of these systems will probably look significantly different than they do today. Like, I think that generally speaking, like, it is a significantly evolving space. And I think, you know, Taiko and Polygon are on like the relatively newer side of things, so like they haven't experienced this yet. But I know zkSync and certainly Arbitrum have already experienced the like development arc of you get the thing you think is really good, and then you discover, oh wait, there's this more we want to do. So I fully expect kind of that arc to continue.
I think we'll agree.
Okay, I'm glad we have.
Yeah, one thing I'd say there, and I realize if Harry was a ZK rollup like a type 2, it would have worked well, type 1 and then type 3 and type 4. But so maybe that'll happen. But
Maybe one day.
yeah, kind of like talking about converging and a bit of future-proofing what Alex was saying before, and like one really nice thing about being Ethereum equivalent is there's kind of two ways to look at it. Alex is looking at the future and then saying, okay, we want to get there and native account abstraction and stuff. But then if you also start from like pure Ethereum and not eschewing any of it, even the hard stuff to prove, you also get a sort of future proofness, which is the Ethereum brain trust and all the solutions that it will come up with to solve its own problems, and then we could plug into and reuse. That's something we talk about a lot, is reusing it. So reusing Geth, and because a lot of these hypothetical differences, like what's the best VM and this and that, it's, we take pride in these like esoteric discussions, and it's fun, and that's what kind of gives us like market niches and narratives. But it's also just like we have to meet the people where they are, the developers, the users, the patterns they know, and again, just like the simple path of reusing just Ethereum. There's so much good work there. So it's a bit of like a different sort of future proofness. If you just stay in tow with Ethereum, you could kind of bet that Ethereum will deliver, and if you could ZK prove that, then you could be good to go, and you don't have to look around every corner. Just a thought.
Okay, great. Okay, this heat discussion. Yeah, so let's move on. I would say, decentralization is one of the most important part for, in the blockchain space, in the layer 2 space. So how do you see decentralizations fit in your solution? Because I understand they're in different stage for different roll-up solutions. So maybe, Harry, you can start?
Yeah, happy to.
Yeah.
So it's interesting in that like it's definitely been a long arc of development. And definitely kind of Arbitrum has very much been on the journey of sort of progressive decentralization and is a lot further along today than at launch, but certainly is not kind of where we want it to be yet. But although hopefully we're closer and closer to that goal. I think it's really interesting in that, like, with the there's a lot of different factors. I mean, one of the biggest ones being sort of this sort of realm of, do you have instant upgradability? Do you have a multi-sig? I think with the DAO, Arbitrum 1 migrated over to having a public security council that's elected every 6 months by the DAO, and I think that was a huge stride. That's a 9 of 12 multi-sig, and I think that was a huge stride towards kind of very real decentralization. And I think the other area that's kind of huge for us, in the area where we're not where we want to be yet, is on validation is currently permissioned. And there's kind of very active development being done on a new version of the Arbitrum challenge protocol that's going to remove that and kind of get us closer and closer. And Vitalik laid out a really great framework of kind of multiple stages of roll-up decentralization a little while ago, where you start from kind of the first stage, which to me is kind of like, if you call yourself a roll-up and post to Ethereum, then you're a stage 1 roll-up, and then kind of to where we are, or stage 0, I forget what, it's 0 or 1 indexed, and then to where we are, where kind of you actually have sort of no, outside of kind of a very high threshold multi-sig of independent parties, you don't have any sort of backdoor to the system, and then kind of the final place where I'm sort of personally, I mean, there's a lot of different variables, but personally optimistic that kind of within the next, let's say, to throw out a number, year, we'll start to see this happen, where you kind of get to sort of the full promise here, which is there's nobody you need to trust in order to know that your funds are secure.
The way we are approaching, as we announced the last weeks, we announced Polygon 2.0. Polygon 2.0 at the end is a constellation of many rollups that will be connected to each other. Why many rollups? Well, maybe some of them are going to be public, some of them are going to be private, and with different properties. But one of the properties is the degree of decentralization of the sequencer. Maybe for some rollups, it makes sense to be a centralized sequencer, but for some rollups, you need a decentralized sequencer with a consensus, with a consensus network that's running this decentralized sequencer. With that, all these networks will be powered by the staking hub, and the idea is, and we are working, it's not in the, I'm more in the ZK part in Polygon, but we are working in this consensus, this stake hub and these consensus algorithms, so that it's perfectly possible to have decentralized sequencers, so that the network is fully decentralized. As I mentioned before, our goal is to achieve the same values that Ethereum, and of course decentralization is a really important one.
For us, the decentralization is the core of our ethos and mission. So we are working on decentralizing the sequencer in the short term, because that gives you reliability from the user perspective, that your transactions are not going to be reverted, and it's really important for a number of applications to guarantee that you have certain checkpoints that have happened with certainty. But we're also working on decentralizing the prover eventually, and the first step was the new proof system, which we just announced, which is optimized for provability on GPUs that are consumer grade. So it doesn't require more than 16 gigabytes of RAM. It can be proven on any GPU instances on demand in the cloud, or on the consumer, like gaming computers, or on the GPU rigs that were used for mining other blockchains and so on. So this was the fundamental step, without which we would be bound to this huge expensive provers with a lot of gigabytes of RAM that you can only run in the cloud, and then the cloud providers have the instant kill switch, which is obviously not the data. So sequencer, the prover, is going to be decentralized as the first steps, and then after that we're going to decentralize the governance. I have huge respect for what Arbitrum has done with regard to Security Council, how they organized all of that with electability and so on. At zkSync, we actually came up with the idea and the name Security Council, like we did it for zkSync version 1, for zkSync Lite. And I'm still not quite happy with this concept, because you still have a multi-sig. And I really, really hope that we can transcend that and go to like have the L2 systems that are completely independent from any honest majority assumption. And I think we kind of have designs close, like Optimism guys published an interesting proposal for burdening layer 1 with resolving the conflicts for a popular rollup, which Vitalik was then against. So like it's, but we need to think further in this direction. But it's critical to us. Like we started zkSync Lite completely decentralized. On L2-bit, it would be called stage 2 rollup by today's standards. And then we ran into a problem. We needed to upgrade it instantly, and we realized it's too early to ossify this protocol, so we had to make a step back. And now it's like it's stage. I think it's stage 1 officially, just like with Arbitrum. Okay. Era is still in the alpha mode, so it's going to be the next step.
Do you still have one?
Oh, thank you. He didn't want me to. No. Yeah. So. Again, a great question from our point of view, from Taiko's point of view. We, besides the whole equivalence that we've really beaten up here, we have permissionless proposers and provers on testnet. Right, Taiko's the only project not on mainnet here, but if you take real test nets that have been live for some months as a commitment and real progress and implementation. So we have permissionless proposers. That means anybody could, we call sequencers proposers. Anybody could create a rollup block and post them to Ethereum. That's great. It has some nice properties, but it's also important to show its deficiencies, right? I find by arguing why people would not want that, it could kind of buffet our point. And what you have with permissionless proposers is not super fast pre-confirmations, right? Like Arbitrum has. So users might love that snappy promise, okay, I'm the sequencer, the single sequencer, you're in, and I promise not to take you out. Of course, you could add some schemes on top to make that more secure, but we have just again, what Vitalik calls total anarchy, and what you extend it like beyond total anarchy on like a mainnet environment and using PBS infrastructure is what Justin Drake calls a based rollup, right? Where L1 validators could be your sequencers, your proposers, because they're already running the PBS infrastructure. So the searchers and builders are crafting the best blocks with the best MEV. Indeed, in our case, not having to change gas costs or stuff like that because that EVM equivalence. So you have the best set of all in terms of potential proposers, which is the Ethereum L1 validator set. So highly decentralized, censorship-resistant liveness. A side benefit for me from a philosophical point of view is enriching L1 validators, which I like. Again, another counterpoint to that is you're not capturing the MEV, right? So again, that's the other side of it. The single sequencer could really capture that MEV. Here you're giving it to the L1 validators, but we at Taiko quite like that. And then finally, on the proving side, again, right now it's permissionless for us. Right now it's a pure race, so fastest proof wins. Just to put some numbers on the testnet, we have like 3,500 people that proposed blocks, okay? That's a lot in this current testnet. For sure, some of them are not doing it because they're the most interested in decentralization. They might think there's some rewards. We're all aware of those sorts of dynamics. But 3,500 people have proposed blocks, and a couple hundred people have proven blocks. It's a drop-off because it's a greater degree of difficulty to prove it. And I want to be clear, that's without full ZK circuit coverage. So it's not super, we don't have, the full ZKPs aren't implemented. So those couple hundred provers, we fully expect to drop down to fewer professionalized provers. And indeed, probably steer away from a pure race, which could be centralizing because the fastest prover will always win. It's deterministic. So we don't want to just reward that first winner. That could, reduce margins. So then actually today on an L3 implementation, we have an instantiation of our Alpha 4 testnet as an L3, which uses auction-based mechanism for prover, so buying the right to prove a batch. I know Jordi and Polygon have written extensively and researched this. And then the third scheme, which again has been written on, is like a stake-based one. So if not auction, but all to say, yeah, we really care about those really decentralized. Like, and we think we're walking the talk right now on testnet to the extent we can, and it's our goal to launch from day zero like that, fully aware of the trade-offs. No perhaps soft confirmations and no MEV capturing, but that's the properties we like.
Two extremely quick things if I can. One, Taiko is based. That's what I heard.
Thank you. Yes, you heard it.
And two, go to L2Beat, which is an amazing resource for looking at the real security of all these protocols.
I'm really sorry.
And numbers.
I'm going to have to be the party pooper, but we're running late. It looks like you guys are having a lot of fun. But we're going to have one more panel talk. After that, any of your questions, come find us out there. Thank you very much.
Okay.
Thank you.
Thank you.